my name is Mike Benz. As you can see from your schedule, there were supposed to be 2 of us up here. There's only one. Unfortunately, Vinny's not with us today. He caught the flu this weekend and so had to bow out. Is unable to join us. So given the last minute nature of the pivot, we decided that I would read what Vinny had planned on delivering. So you'll just have to picture me with an epic beard in the slides that Vinny would have read. And if it looks like I'm reading directly off the speaker notes for the Veeps slides, I am, because I'm reading his words on that. So, all right. So as you can tell from the title, this is somewhat of a soft talk. While I'll be talking about some of the technology and the tech decisions made. We'll primarily wanted to tell the story of how Veeps and DockYard worked together to get to where we are today and where Veeps will be in the near future. So a little bit about me. I've been doing Elixir for about 7 years. I've been with DockYard for 3. My socials are up there if you're interested in following up or chatting. I have a couple of Elixir libraries that I put out. The most recent one would be Cobalt to Elixir. Like I said, I'm hoping to maybe do a lightning talk on that to introduce that a little bit. And then a little bit about Vinny. Vinny was fortunate enough to be at the helm of multiple platforms that have served some of the biggest names in the music industry. One of them he joined and whipped into shape. Another he co-founded, which was acquired by Eventbrite. And now he's back up in startup land at Veeps. Fun early 2000s anecdote, Vinny toured the intercontinental US as a professional drummer in a signed national act. But after being broke for a few years and selling literally dozens of records, he decided to limp back over to the technology side of music. So just a little bit about how things started. So Veeps was founded in 2016 as a platform to sell VIP packages without commissions paid by the artist. The company has a nice deck stacked with music industry veterans and deep empathy for its customers. Quite the recipe for success. Fast forward a few years and COVID hits. The pandemic decimates the music industry. Turns out selling tickets to something that's predicated on your ability to gather isn't all that fruitful during a global lockdown. Veeps pivoted to continue helping artists by providing live streaming as a feature on the legacy platform. This pivot worked. Live stream attendance began growing exponentially. Trawls of fans are able to enjoy live music, and artists discover a new revenue stream. Now Veeps has a new problem. The app was never designed to take the brunt of incoming traffic walls, not of this size anyway. Quick ticketing footnote. A show's sell-through cycle effectively works like this. The announcement is a massive burst of traffic and sales, followed by a lull, and then a steep day of ramp-up, bookended with a tsunami right before the showtime. And with 1 engineer on staff, they needed help. Vinny's old co-founder / longtime friend reached out about some of their struggles with the new pivot, resulting in chats with the rest of the leadership. Vinny was enamored with the potential, vision, and most importantly, the team. So he joined Veeps in July 2020, knowing they had a lot of work ahead of them. So as far as the existing setup, they had, as we mentioned, Veeps had 1 engineer on staff, and they had 1 Rails app ripe with technical debt. Vinny had seen all of the problems encountered previously, but never in a single app. Same with the scaling demands. They're usually on a longer timeline. Turns out whack-a-mole is a challenging game when all the moles are popping up at once. In the beginning, there was a lot of low-hanging fruit. There was process where they added a test suite, instrumented the system, enforced code quality, and performance tweaks, caching all the things, only ask for what you need from the database, indexing tables correctly, searching through Elastic, make the inventory system not so database bound, those sort of things. All of this work gave Veeps accountability, observability, and a few more orders of magnitude in what they could handle in traffic, which is great news, but it wasn't enough. So that brings to the big ask. The question was, how quickly could Veeps support a major act like BTS or a One Direction reunion? with what they had, it wasn't going to happen. Luckily, leadership was fantastic and came back with, tell us what you need. What Veeps needed was more engineering might. They needed to make this an engineering-based company. So the new problem statement was, building a world-class engineering team takes time, especially considering that hiring great people is one of the hardest things to do, let alone accelerate. Veeps decided to kick off the hunt for the right people while augmenting their staff with best-in-class engineering. The decision was made to bring DockYard into the fold. DockYard has a multitude of languages and framework core members and creators in their stable, a proven track record of delivering value to some marquee nameplates, and their staff with craftsmen. Veeps had stretched the Rails app as far as it could go without rewriting the vast majority of the app. And since they were already in the realm of total rewrite, it made them question if the technology choice was still correct. Knowing they wanted to expand the amount of real-time interactions and handle 10 or 100 times the traffic, they decided that Elixir was the future of Veeps. It was now time to begin the enormous task of re-platforming. But first, one of the warts that Veeps couldn't get to as a small team was ditching the Postgres schema-based multi-tenancy. Being an early decision made before Vinnie arrived at Veeps, it was already a threat when he joined. The gem creators, in this case it was the apartment gem in Ruby, themselves wrote in depth how they ultimately ditched the approach and how it doesn't work well for systems with over 100 tenants. Veeps had thousands. This was not a small problem, as the legacy platform had numerous integer-based relationships fragmented across thousands of schemas. DockYard took this work across the line for Veeps, completing the migration away from schema-based multi-tenancy, which set them up for the next phase. The next phase was to figure out what the thundering herd problem where the thundering herd problem would surface in the new app, and architect a rock-solid solution to handle this situation. And the situation you see here is the one that we spent a great deal of time working through and processing and trying to figure out the best way to deal with. So if a top artist tweets an event link to their 100 million fans and 1% of them click it within minutes, we need to sell exactly 20,000 tickets and 500 t-shirts without lagging and don't crash. Right, so that's the problem that we were looking at. That was the core thing that we realized we needed to tackle first. So the approach on that was, to restate the requirements, basically there was going to be a wall of traffic, thundering herd. So within 60 seconds you could get 1 million people hitting your website. We needed to allow the user to cart only the available number of items. So if there's 500 t-shirts, the first 500 to add them to the cart would get them. And anyone beyond that would get a waiting room experience that, that there's none available right now, but maybe those reservations, maybe those will drop out of someone's cart and then become available. And after 10 minutes, the cart would expire and return those items to be available for someone else. And so those are the requirements we were working off of. So the system, we came up with a reservation system. And this reservation system has multiple layers to it, and we'll start from the bottom layer and work our way up. The bottom layer was the database, the persistent part of that system. And so what would happen is that reservations would be granted to users and stored in a database. We split the concept of a reservation out from the concept of a cart entry, so that because we wanted to make sure that the reservation system, because that's where the greatest amount of work is going to happen, the most amount of traffic is going to happen on the reservation table. We wanted to keep that very clean, least amount of least amount of interaction with that table. And so basically, if you have a reservation without a cart entry, it means that someone has removed a cart, something from their cart. So that reservation would then get cleaned up. And then the next person who's in the waiting room would be notified, hey, there's one available. if you have a cart entry where the reservation has been reclaimed, it means that that's expired, and so we need to tell the user, hey, your cart, this thing in your cart, you no longer have a reservation for it, so you need to recart it or retry to cart it if we're out of them. And like I said, yeah, that was to protect the reservation table, make that have the least amount of work going on in that table. So that's the database level. And if we take one step up, we have OTP, which is where obviously Elixir's starts shining, where we have, so to explain what a product variant, so let's say you have a t-shirt that you're selling, that's your product, but you might have 100 small, 100 medium, 100 large, and so those are the variants that you have. So for each product variant in the system, we spin up there's a gen server for it. It's on demand, so if something is not currently, there's no actual traffic, that gen server will spin itself down. But as soon as the first person says, I want the medium concert t-shirt, we spin up a gen server, and that gen server is now the point of contact for getting those reservations. So all reservation requests go through this gen server. Obviously, that has a potential to be a bottleneck, and so we offload as much of the work as possible into batches. So when a live view process says, hey, I want to add this shirt to my cart, the gen server will take that request, add it to its internal state, and then call a no reply. So the calling party is still waiting for that reply. And then on a 500 millisecond cycle, we then go through and we take all of those requests, batch them, and then send that reply, the gen server reply to all those processes that are trying to add a cart. So the client, in this case, LiveView, sends a request. After a little bit of time, it gets that response back, but in the background, we're batching. So it allows us to use gen servers as a source of authority, but still get batching and high throughput. And these gen servers are on a separate Elixir app on dedicated nodes. So we have our LiveView front-end nodes that are getting traffic in, and then we have nodes that are running the product server gen server. So we have database, we have OTP gen servers, and then the next level is an ETS table. And on each node that is running these gen servers, there's a table that can be referenced across that node to say whether this item is in a soft sellout state or not. Because as soon as there aren't any available, you don't need to jump into the gen server to say, hey, can I have a reservation? We already know that the answer is going to be no. And so the gen server, as soon as it enters a soft sellout state, updates the ETS table and says not available, and then that way the next request doesn't have to go into that. The gen server is still the authoritative, so if there's a time where the last item has actually been handed out, that next request might hit the ETS table and say, oh, and enter that gen server. Gen server would then say, sorry, it's actually not available, and let the user know. And on top of all that, we are using, as I said, our gen servers are on one node, and our LiveView processes are on a different node. And so we are using node.spawn to make those requests into that other node. And that way, that node.spawn starts a process that's able to be parallelized on the other node and can immediately check the ETS table, and if it's unavailable, replies, and there's no bottleneck at all in that. All right, so that's the reservation system. Like I said, we've got database, we've got OTP, we've got ETS, and then our node spawn communication system. And so that was the first part of the process that we got up and running in proof of concept, and then iterated on that. The next step was that we decided, or the next thing to tackle was the actual LiveView front-end store experience. And so at that point, all we had some wireframes of ideas and some high-level spoken requirements. So we realized that we needed to pivot and go through a tech discovery process and really understand what it is that Veeps wanted and how we were going to deliver that. All right, so as far as the technical discovery process, we started out with, in this process, we got Veeps, all the Veeps stakeholders and all their engineers and the DockYard engineers into a room, or into a Zoom, and we went through the number of different steps. The first one was simply the groundwork, so that the engineers at DockYard and the engineers and the product people at Veeps were all on the same page about what we're really aiming for. So we talked, Veeps shared the product vision, the mission, the roadmap, and the personas and research. So that way, we as DockYarders who are coming in new to this process could really understand where Veeps is coming from and kind of get into that mindset of where they're at. So we used a process called Lean Canvas, and if the tool we use for that is called Mural, and if you haven't seen it before, Murals, it's basically the idea of having a whiteboard and having sticky notes that you can write on and throw them on the whiteboard. It's just a web-based version of that. So we use that for a number of these processes. And so the initial team, the initial Lean Canvas really helped, again, work through that groundwork of who Veeps is, what their strengths are, why they're doing what they're doing, these sort of things. I had to blur out the actual data because Veeps didn't want us giving away their secrets, but each one of those is a little sticky note. So yeah, so things like key metrics, unique value proposition, those sort of things. Really, again, to get the engineers into that mindset of who Veeps is and what's going on and how to operate. So then we moved on to user story mapping. And so here you can see at the top, the three blue boxes at the top are epics, features are on the next line, and stories listed down there. And those we prioritize those most important down to least important, and that'll come up in a little bit. But the prioritization process, we went through all those features and epics and user stories, and from the Veeps side, Veeps decided the impact to the business and the impact to the user on a 1 to 5 scale to decide what it is that is going to be the most important. And then DockYard, from an engineering side, went through and scaled each of those things on a complexity and unknowns and risk type of thing. So given those two data points, we can figure out what's most important and where we should be focusing. And then, so to get back to the mapping, we then drew a line, basically. And so you see the stuff above the line is release 1, stuff below the line is release 2 or later. And so through that process, we were able to figure out really what it was that Veeps needed, how DockYard could come alongside them and work through that. And so DockYard made a proposal for what the team would be that we would come alongside Veeps with. And so we mapped out, there was a lean, a mid-size, and a stacked option, and really showed Veeps, look, if you go with this option, you'll have this sort of a timeline, you'll get these features, you go with this. And they were motivated and went with the stacked option, which gave them the best timeline. All right, so now we have a full suite of DockYard engineers, Veeps, everyone's kind of on board with what the plan is, how we're going to move forward. So we move into the main phase of actually getting this stuff done. First, though, again, as I said, at that point we brought on a number of additional engineers, and so we wanted to make sure this team was all going to work well together. Because if your team, I don't know if for those of you that were in Miki's talk, which was amazing, if you didn't see it, catch it on the recording. If your team's not working well together, Elixir's not going to save you. That's not going to, it's not going to fix that. So we went through a similar team canvas exercise to get everyone back, get everyone up to date on the the purpose, common goals, values, those sort of things. So we really understood what it was that we were going to be building and why. Then the next one was an individual team canvas, and I think this was probably one of the most important things that really got the team on the same page, where we went through these sort of questions, and we really it allowed those of us on the engineering team to really kind of figure out who each of us are, how we work. You can read them here. Why I care about this project. So we had some of the engineers have music backgrounds, so learn that sort of stuff. What their role was going to be in the project, and the personality and working style was huge. So one thing that came up was that my style of working through code issues with other engineers isn't one that works for everyone. If you send me an error or an issue you're having over Slack, by default you're probably going to get a Google Hangout link back so I can jump in and take a look. Another engineer, Amy, however, noted her different style in this team canvas exercise. Amy works best through issues in a text format, so processing the words visually. And so she prefers to stay in a text chat instead of jumping into a Hangout. And if we hadn't gone through this team canvas exercise together, I would have probably made her life miserable and not known it, because she would have sent me, hey, I'm getting this error, and she would have gotten a Google Hangout back instead of being able to work through it in a way that worked well for her. So it was a really awesome thing to figure out, and it really shows the importance of this sort of exercise in a team when you have a new team coming together or new team members. The other anecdote from that was that one of the things I noted was my dad jokes are kind of a thing that I do, and so when one of the engineers later in the project posted a PR review for PR number 404, and I replied, PR not found, he was able to connect that, that's just Mike being Mike. So, all right, so that was the individual team canvas that we did, and then we moved into actually getting some of the work done. And so as far as our meeting cadence, we had engineering startups daily at the beginning, and then we paired that back to, we made half of them virtual stand-ups in Slack to just post your status. We had so we had 2-week sprints, and we had code walkthroughs at the end of the first sprint, where we just talk about interesting, with live view, there's all sorts of different paradigms that we were working through and adding to the project, so talking through things like that. And then at the end of the sprint, we had the sprint demo, and then an engineering retro, where we really dove into what worked well this sprint, what didn't work well, and what we can do for the future sprints. Some of the technical stuff. So GitHub, we use branch protection. So at this point, we had probably 10 or 12 engineers all working together. So we required pull requests before merging. So that prevented engineers from throwing stuff right into main and breaking that. We required 2 approvals before merging, which forced code reviews. With this team, we wanted to make sure that we were really all on the same page about what sort of code we were writing, the paradigms we were introducing, and really have everyone understand the code that was going on. So we had the 2 approvals. Status checks before merging. CI was required, so obviously if you're failing CI, we wouldn't let you merge. And we did note code coverage with coveralls in the PR, but that wasn't a requirement. We wouldn't prevent a merge if you didn't have that. It just helped the team see where things were heading. And then required branches to be up to date before merging, because that's another way to break main, is to merge something that passed in CI, but with an old main, or based on an old main. So. Let's see. So the other thing that we had was we had Git Hooks set up. So there's an Elixir Git Hooks dependency you can add. And before on pre-commit, so as you go to commit, it's going to check and just make sure that your JavaScript is linted correctly, which it should be, because we had tools to keep that in line. And then the things are formatted, because it should be pretty easy to get that back into line formatted. When you go to push, it would run those 2 checks also, and then it would make sure that you don't have any warnings in your code, so it would clean and then compile with warnings as errors, and then it would run Credo and Dialyzer. A note on that, so Credo recently had some really good speed improvements. If you're thinking that putting Credo in a push is problematic because it's slow, it was, but some of the more recent ones, updates have made that basically lightning fast. And then Dialyzer, which again, as long as it's been run recently, is a pretty quick check. So that's on the developer machine before things get out into GitHub. Once it hits GitHub, we had GitHub Actions set up, and we run again the same 5 things that were run locally. But then we actually ran into a couple issues where Webpack early on, Webpack was CI all passed, but Webpack actually didn't build, so when it went to deploy, it failed. So we built Webpack, make sure that passed, and then obviously running the tests using mixed coverall, so we get the test and the coverage all in one shot. So another thing that we used at Veeps is the concept of a preview environment. So often what you would have is that when something gets into main, it would, especially in a pre-launch, a pre-prod time, you would have a staging environment, and whatever's in main is running in stage. However, when you have a large number of engineers, that could be turning over pretty quickly. Someone else could have an issue, change something that causes something that you're trying to look at to not work how you thought it would. And also you might want to be able to spin up your code in a real environment before you actually merge. And so the preview environment allowed you to jump into GitHub Actions, drop a commit hash, and it would spin up an entire environment with that commit hash, so with its own database, its own seeds spun up, so that you could, in isolation, test the stuff that you're working on and see how it would work. This was also great for QA, being able to spin up their own environments to test a feature on a branch and do their work without being disturbed by the system going down because someone else pushed a new version and we're spinning up a new staging. And so it would spin it up with a random subdomain host, and you just grab that out of GitHub Actions, and you can then see what you're working on. And they spun down automatically after 24 hours. It was to quote I think it's the Docker mentality of they were cattle, not pets. So you spun one up, and the next time you needed something else, you spun another one up. Let's see. So another thing we had was we had a script that we ran, so oftentimes with this many engineers, you've got people adding all sorts of new things into the code base that you need to then deal with after you pull main or you rebase. And so this simple script, after you pulled main, you run this, step away, get a coffee or whatever, because it takes a little while, but it would go through, make sure that if we had updated the version of Elixir or Erlang that we're using, ASDF install would take care of that. If there's a new there's a new hex or rebar, it would grab those, pull the new dependencies. It would run mix ecto migrate, so any new migrations that were added in would get run. Early on in the project, before we swapped over to migrate. We actually did mix ecto.reset because we were at that point early on. We were updating the migration files, but then once we made the call to swap to no longer updating those, we just add the information afterwards in migrations, and npm install, and then run the git check to make sure that you've just pulled the branch, make sure that everything is all running how we expect it to. The second and third to last ones there probably aren't native ones, and I'll probably actually put a blog post out on what those are and how we got those working. So yeah, so that's what we did, and we went through we wrapped up the main feature work with that a couple weeks ago, and so what's next? What's next on the DockYard side of things is that we're working through a session of monitoring and instrumentation. So we're going through and saying, how can we have visibility into this so when that wall of traffic hits, we can easily see if and where things are having issues, where the slowdowns are happening. So we're identifying and instrumenting the potential hotspots, digging right now into live view telemetry and feeding off of those events. And we're using app signal to track that. Next step, once we have that visibility up and running, is that we would start doing our static load testing. So we will request make the initial HTTP request and then connect out using a socket to test that, and then dynamic benchmarking on the internal side to really start hammering on that product server to make sure that it's able to handle the amount of traffic that we're expecting to be run through that reservation system. And so then after that would be launch. So ETL work from the legacy database is currently in progress with the help of a few more DockYard folks. And then the new platform will launch in late November. None of this could have happened without a massive assist from DockYard or the willpower and perseverance of the small but mighty team at Veeps. Veeps has huge things coming in 2022, including the expansion of their engineering team. So please reach out if you love music, real-time interactions, and products that bring fans closer to artists. And that's it.